Alright, last one, we got a little trig going on here. So for our derivative, the 4 sine cubed, we're going to use chain rule there. The 4 stays out in front. We have to do the derivative of the exponent first, then the sine. So bring the 3 out in front. We get 12 sine squared of x. And then we multiply by the derivative of sine, which is cosine of x. Plus, over here, bringing that 2 out in front, we get 6 square root of 2 times cosine to the first of x times derivative of cosine of x. So again, we have 2 parts here. So derivative of cosine is negative sine. So I'm going to go ahead and put that negative up front here. Get that a minus. And we want to figure out when this one is 0. Right? No fraction here. It's not going to be undefined. So we want to know, when is this equal to 0? Well, to do that, first I'm going to go ahead and do a little factoring. I can take a 6 out of everything. I can take a sine out of both and a cosine out of both. So I'm going to take that out, and we're left with 2 sine of x minus square root of 2. So we've got a few things here. We've got sine of x times cosine of x times this. We basically have 3 things getting multiplied here that could equal 0. We want to know what makes sine of x equal to 0, what makes cosine of x equal to 0, and what makes 2 sine of x minus root 2 equal to 0. So this is where we need to depend on our knowledge of the unit circle. Right, so we want a sine that's equal to 0. Well, that happens here and here. Right, the sine is equal to 0, y value of those 2 angles. So that would be pi and 0 pi, or pi, 2 pi. So x is going to equal 0 plus pi n. Right? We can find all the coterminal angles here. So this would just be pi times n. Because that would take into account 0 pi, 1 pi, 2 pi, 3 pi, also negative pi, negative 2 pi, and so on. So that gives us a set of answers for critical values. Cosine of x is 0. That's going to happen when x is 0 on the unit circle. So that's pi over 2, 3 pi over 2, and all the angles that are coterminal with it. So for this one, we have pi over 2 plus pi n. And that will account for all of those angles. Right? We can just add pi n because they're directly 180 degrees or pi radians across from each other. This last one, we have to do a little solving. We get sine of x equals root 2 over 2. And add the root 2, divided by 2. So when is the sine, or the y value, root 2 over 2? That's going to be at some of our pi over 4 angles. This one we can't write as one equation. We're going to have to write as 2 separate ones. So we've got pi over 4 plus all the coterminal angles with that, so we'd have plus 2 pi n. Right? Add 2 pi to get to another one, add 2 pi, and so on. And then also 3 pi over 4 plus 2 pi n. Right? This angle and all of its coterminal angles. So this accounts for all of our critical values.